It's once again a Wednesday morning, and it's time for another stand-up vlog in this course. We will have a lot of stand-up vlogs in this course since it's a 20-week course. So
Yeah.
it will be more or less 20. Not really, because I don't want to have stand-up like after Christmas. But other than that, we will run stand-ups until the, I think, 14th of December, first of all. Welcome. How are you guys?
Very good. Thank you.
Good enough.
Good enough. You have a big list of courses on your
Yeah.
your whiteboard, Mats. So you're
Yeah.
starting to get busy this study period. 4 courses. That is a lot.
Yeah. A lot of administration. Yes.
Yep. Okay, so let's get down to it. Should we start with the first assignment, Diego? It's I mean, everybody got their feedback and they are working on the complementary work. And you posted something yesterday, I think, about getting to be able to understand one of the main problems that we had with that assignment. They should divide themselves 2 by 2 and start trying each other's projects,
Yeah.
right?
Yeah, I think that there were like five of the projects who had these problems of hard coding information local to the developer. And as promised last week, maybe it's difficult to see the problem if you are working alone in your machine. So yeah, we share each other project so they can try to deploy using the infrastructure as code from another who also has hard-coded information, so they can. It's possible to find personally where are what are the issues.
Yeah.
Some of the. I will start grading on the 11th. No, this was the date that we agreed.
Yeah. So Friday is the deadline. Friday, late Friday. Yeah.
There are some fixes already submitted. So good. It's done well ahead on time.
Yep.
Yeah, some assignments. The problem was to change a couple of strings.
Yep.
It was not so hard to fix. So some hard-coded information that did not allow any other developer to work on that project, but it was not so difficult to fix. So they some assignments have been fixed quickly, but we will start the grading all of them in batch the 11th. So far.
Yep. Great, and you find Diego's. You wrote a post about this in Slack, and I pinned it now as well. So it's findable there. And if you want someone, if you don't have anyone to exchange projects with, you can always like find each other in that thread in Slack. So good. So that is the first assignment. So also for those of you who didn't release that assignment at the original date, you have the re-examination date tomorrow, Friday. So don't miss out on that. The next one will be, I think, June or something. So try to fix the assignment this time. Talking about assignments, we are also live with the second assignment 2, that is for the software patterns and architectural part. And we could actually have a look on that assignment. Maybe there are a few words to say about it. And I will have prepared this, but I didn't. Let's see. So you go, okay, no, that doesn't matter if I'm not logged in. So it's this one, assignment 2, software patterns and architecture, and this should be generated for all of you. So you have your own, as usual, project. The main goal for this assignment is to extend the just task it example application, and for which is the most of you that took 1DV013 a couple of years ago, you are probably familiar with the just task it application, since we used that as an example in that course. But basically, it's a really, really simple application. It's just a to-do list, but it has some features that are good in this case because it's using sessions. The sessions are not used for logging in, but the sessions are used to show those flash messages when you post something and when you delete something. And it will be kind of nice when we put this application up in a cluster and create many instances of this service. We will run into problems with the sessions. So you need to fix that, basically. So in short, it's some things that should be done. First of all, you should create just like you did in assignment 1, you're supposed to write a assignment report. We can have a look at that soon, but you will find that in report.md, and you will write your answers in that file as well. But the main thing is probably the application. And first of all, the application should be an extension of the example application, the Just Task It application. You can, of course, start from the really bare application that we used in the course a couple of years ago, but you can also start with our template where we have created the infrastructure code for creating Kubernetes in the cloud and things like that. So you could start with our example, and this is what is linked here. You should be able to, when finished, you should be able to continuously deliver this to a Kubernetes cluster using a GitLab pipeline. So that is one of the requirements as well. The Task It service, so this is the service that was included from the start. You should treat that as a service, and it should not be stateful. And that is a big thing, as you probably know, when it comes to microservices and running microservices in a cluster, that you don't want the services to be stateful. Because if you try to create many instances of that service, then you will run into a problem. And what is the problem with the service right now? Well, the Task It service is using a document store for storing its persistent data. We are using MongoDB for that, and that isn't a problem because this data isn't stored in the service itself. However, the sessions are stored in the service in memory, and that makes a huge problem when trying to create many services or many instances of the service. So you need to use some kind of key value store for saving the sessions, not in memory, but on a separate session store. We have some example techniques you can use in the bottom. Among others, we are mentioning Redis, and I would probably recommend using Redis for the session store. However, you are free to do whatever you like. I know that some have used actually the MongoDB as the session store. However, I'm not too glad to like share this, so you have put everything in the same database. It's better if you want to use MongoDB as a session store. I would recommend having two separate MongoDB instances, one for the session store and one for the document store in that case. But I would actually recommend trying out Redis because it's widely used for this. Then we come to the newly added features. So we want a feature that put completed tasks in a queue, it says. So we want this service to be able to communicate to Slack. So whenever you add a new post or task to the service, it should post to Slack and say, hello, this was added or created or something. And when you finish a task, it should say in the notification service that this one is finished, and so on. And the way you should implement this is not by letting the Task It service talk directly to Slack. That would be doing too much in this service. Instead, this service will put messages in a queue, and then we will create a new service that in this case is called notification service. You can call it whatever you like, but this notification service will read messages from the queue and is responsible for putting those messages on Slack. We we'll get we can have a look actually at the steps. So first of all, we need to prepare. What do I mean by that? Well, you need to have a Kubernetes cluster to be able to put this in production. You don't need that from the start. Of course, you can work locally with a cluster, just like we did, and you should be able to do that as well. Work with like Minikube and just being able to work with this locally. However, it should also be live on a production cluster. We recommend you're using CS Cloud. We have been hard at work, or at least Stefan, our IT technician, has been hard at work with CS Cloud, updating all the hypervisors. So if some of you noticed, he called me actually at 6 o'clock this Saturday and said, I know, I can go into work now and update the hypervisors. Could you just like make sure that GitLab and CS Cloud and everything is down? So I had to work Saturday as well, but now it's updated. So that's a good thing. It's a preparation to be able to update CS Cloud in the future to a newer version, basically. And maybe we will have clusters built into that version without needing to creating them. But we provide, basically, if you follow the exercises in the course, we provide the Terraform scripts or Mats actually provides the Terraform scripts for creating the cluster. So you don't need to write those yourself, but you need to be able to run them.
It works, but I see on it like bad practice, but it works.
Yeah. And we had some problems as well, Mats, with Windows, right?
Yeah, when you clone to a Windows machine, well, it depends on how you have configured Git, but all line enders will be replaced with character turn line feeds instead of line feed that Bash requires to execute the scripts correctly.
Yep. So when you put those bash scripts into the CS Cloud instances and they try to provision those bash scripts, then it will basically say, no, I don't want to. So you need to fix the line feed, the line endings on those files. But I think, Mats, in Slack, there is a thread about this, so you can just with a solution as well. I had no problems with it on Mac, so that worked, and it should work on Linux as well, I think. But it's a Windows issue. But that's basically the preparation. You need a cluster, and at least you need the local cluster so that you can develop on this. So next part. Well, you should set it up, and I would actually recommend you set this up pretty early so that you can, when you push to GitLab, you can put it into production so you can see this workflow as well. How you do this is basically up to yourself. You can just make it continuous deployment all the way, so it just deploys to the cluster right away, or you can deploy it manually, as I've shown in the demo, or you can and you can choose if you want this on for every commit in main, or if you want to have some branching strategy, work with merge requests. That's totally up to you. I think that things like this will be more specified in the project to come, how to work with this. But in this project, it's important that when you push something, you should be able to get it on the cluster with the help of GitLab. Then we come to the service. As I said, there are 4 flaws in this service. The sessions are stored in memory and not in the session store. That you need to fix. There are no notifications when a task is completed. That is also a must fix. This one I didn't mention before, but the data should be persistent. So you should actually make sure that the MongoDB data is stored on a volume. So you need to handle that. And Morgan has a really good demo of how to do that in CS Cloud with making sure that the database data is stored on a separate volume. There is no authentication or authorization in this application, which is really bad since it's public to the internet and everybody could just go in and add and remove tasks. However, this is really a simple example application, and the focus is not on writing server-side services. So this one is an optional fix. Of course, you can fix this if you like, but it doesn't matter because in this assignment we doesn't care basically. And you should notice as well, when we describe this, it's described like this: handle the second floor by implementing the asynchronous single receiver pattern between the tasked service and the new service called notification service. Yeah, so those fancy words, you really need to read in the book as well, because these are patterns from the book, and in the written part of the assignment, you need to explain those. And we will get to that. The notification service, it should basically just put a notification like this: by milk was completed by, and your username. So you should just include your username in all the messages in some way. All the messages will be sent to a specific Slack channel called 2DV013 notifications, so you can join that one. I would also recommend that you mute this one as soon as you join, because all messages will be put into this one by a bot that Niklas created. So and the credentials for that bot you will find in the security project, a secure project, secrets project it's called. Niklas, do you have anything to add, to say about that bot? Is it straightforward?
It's quite straightforward. I think you have to solve it yourself, but it's probably one Google away.
Yeah.
Like to actually do this.
Yeah.
I made it in C# in like 10 lines of code, so that shouldn't be a problem.
No. I should have added one thing here. I forgot, but we'll say it and see how many who does it. But you will get an access token for the bot, and that access token should not be embedded in the code. No. It should probably be placed as a secret in the cluster. So do that, just as we discussed in the demo with the session secret. That should also be a secret in the cluster. But
some of the things should be secrets. Some of them should be config maps. Yeah. Probably.
Yeah. Not secret stuff. Config maps. Secret stuff. Secret. That's
the advanced part.
Yeah.
Fast.
Yeah. So please just think about that as well. Yeah. We have some recommended techniques using Redis as the session store, as I said. And I mean, this queue here, we are just saying that you should implement a specific pattern, the asynchronous single receiver pattern. However, if you read in a book, you will see that, RabbitMQ is one implementation of this. There are other examples. You're free to use whatever you like. Yep. You have tried with RabbitMQ, Niklas?
Yeah, it was quite straightforward. Really good documentation and support for multiple languages. You should not build this queue by yourself. This is not a service you build by yourself.
No,
you use some kind of
use something else.
Use something else. Do not do it by yourself.
Yeah, and that is, if we look at the picture, this one in the middle.
Yeah,
that makes this work. And this is kind of usual as well, that you, in the case of RabbitMQ, you are actually installing RabbitMQ into the cluster, so that the cluster has RabbitMQ included.
Exactly. And the recommended way of doing this is using Helm, which is like NPM for Kubernetes. It was pretty much those 2 lines of code you see at the top there. I used.
But then you need to go into the cluster and install it into the cluster. Yeah. And this is actually, I talked to one developer at Cinch, and he told me that I think he said that they have, or had, this was last year, he had like 80 clusters or something like that. And all developers wants their own tools in the cluster. So someone Helm, someone to RabbitMQ, someone wants Istio, someone wants this and that, and so now we're getting into the problem of if we talked about solving the problem of Snowflake servers. A Snowflake server is basically two servers being kind of should be the same, but they are not because they have different tools installed. We are solving this by, as Diego showed, Ansible, for instance, to make sure that those servers are perfectly the same. Now we're getting into the same problem in the clusters.
Yeah.
So we have a lot of clusters and everybody will have their own tools. And now we're running into problem how to handle this. And of course, there are tools for that as well. So we can add a tool up on top of our clusters to handle dependencies and making sure that the clusters are the same. So if we have a development cluster and a production cluster, we want them to be identical. Otherwise, we will get into same problems as with servers, that we put code in the development cluster, it works, move it into production, it fails because we have different versions of the clusters.
Yeah, this is a little. I'm not really happy about this. I would like us to configure everything, but when you look at the configuration for something like RabbitMQ, it goes crazy really fast. And it's I understand why you use Helm, but it also destroys some parts of the really nice parts of Kubernetes, I think.
Yeah.
But I think the tools you're talking about is outside the scope of this course.
Yeah, we can just mention the Rancher. Rancher is one of the tools that could handle this. I think it's free to use, at least for students and for private use. I don't do pricing. Well, then I just guessed that it's free for students. But I'm pretty sure it is. So this is actually, you can add your clusters to Rancher. And I mean, even now, I have two clusters now. Niklas, you have a couple as well, and you bought one on DigitalOcean and stuff like that. And then you can add those clusters into Rancher. I guess you install an agent or something in the cluster that connects to Rancher. I don't know. I haven't tried it yet. But then you can handle packet installations with Helm. You can handle that as a one-click installation. So if you want RabbitMQ, you can just go in and install RabbitMQ into the cluster. But then you can also make sure that they are the same. And actually another developer I talked to at Tieto, he told me that they are using Rancher because a lot of customers, they don't want to have... It's not enough to separate customers with namespaces in the cluster. They want their own clusters totally isolated. And then they said that Rancher is a big help for that as well. So that could be...
namespaces is not a security.
No, exactly. And there are other tools. I think K9S is one tool to handle this. It's just a console application, and there are probably a few more, but I've heard Rancher from different kind of developers using this, so I think it could be great to look into. We will probably not do that in the scope of the course. However, we will have some guest lectures soon during the project phase of the course, and maybe some will talk about Rancher actually. Okay, yeah, so having Helm, I don't remember, Mats, in your scripts if Helm is included in the installation. No, so you need to install Helm manually or add it to the bash scripts that you're using for provisioning.
You could pretty much provision RabbitMQ. If you know you're going to use it in your cluster, you could put it in your deployment scripts.
Yep.
That would be nice to try it out.
Yep. So this is basically the application that should be built. You have 2.5 weeks for this. I mean, it's not a lot of code. It's I don't know, but not much code. It's more configuration and understanding things and configuring things in this case, and it's not a coding course in that sense. So we have a report as well with some questions. I think the main one is this 1.1 software patterns. So you're supposed to describe which software patterns are implemented in your solution using chapters 2 to 4 in the course literature. Patterns in other chapters are optional, so you can use patterns for other chapters if you like. You should include a reflection about each pattern and how it is implemented. You should be able to identify at least 5 patterns, even though more may be used. I think that you will have at least 6 or 7, I think, patterns from the book. But you only need to identify 5. But please, if you want, you can identify more. Just a tip. I mean, it's not entirely sure that you have implemented all the patterns. It says not that patterns that you have implemented in your solution. It's patterns that are implemented in your solution. So some of the
you
patterns,
can identify.
Yeah, some of the patterns you might get just by having certain stuff. And yeah, I will not say anything more. You need to read, and then when you read, you will know what I mean. Just some words about virtualization and orchestration. We would like to know why it's important as a developer to be able to work with not only Kubernetes, but Docker Compose, and Kubernetes. You should also describe the problems we have with sessions in the GT, and how you why you had to create the separate session store. I basically said that was one today. The queue. Describe the problems you solved with using a queue, and you should also reflect on other ways we could have implemented this instead of using this asynchronous single queue. And reason about pros and cons when it comes to development environment in this assignment. So it's a pretty advanced development environment with Minikube and tunnels and stuff like that. So just your thoughts on pros and cons with working with this, and think of, for instance, this kind of application, kind of few services, two services, a couple of other systems involved as well, and think larger. So if we were to have 20 services, 30 services, when you write that reflection. So that's what you need to include in the report. Okay. Do any of you have any questions? Because it might be the first time you see this. I think that Niklas and Mats, actually, you read it yesterday, maybe. But...
Yeah, parts of it, anyhow.
Yeah.
We don't have any questions from the chat.
No, not that I can see, at least.
Put a link to the notification channels in the standard cloud native channel in Slack.
Yep.
So you can find it.
Good. That is basically it. Yeah, I saw that some had problems with installing, but there was a long discussion, and I was mentioned, but then things got fixed really quick. So I just thought that I will wait until things stabilize and then see if we need help. It's the same with assignment. Maybe next week we could have some kind of, next or the week after, we could have some kind of tutoring session if you run into problems or something like that. But please let us know, then we could plan something.
Yeah.
And about the, I mean, it's, you need to be aware. Also, the problem in this is not like writing that the code is super hard to write. The problem with this assignment is it's a lot of techniques that work together. It's environment variables, it's secrets, it's clusters that are configured. It's a lot of stuff. So you need to be really organized when doing this. Use a pen and paper and write down what you're doing, in which order. Put a log in a document where you write, I run this command, then this, then this, then this. I got a somewhat mysterious output in this case. Write it down so you know, and make an explanation mark so you know that if something is wrong later on, might be because of that step. And this is kind of the DevOps life, I guess.
Yeah, this is a lot of moving parts here, so we need to understand enough, at least, to be able to understand when it goes wrong, where does it go wrong.
And even though we have tried it on Mats' Windows machine, we have tried it on your Windows machine, Niklas, we have tried it on my Mac. Who knows what will happen on another system? It might break. We know that it should work at least in CS Cloud. However, remember, and Mats, you did a good job in the instructions, when you provision the service in CS Cloud, some service will just not be provisioned and join the cluster. Then you need to read Mats' instructions because it's prepared to be able to join them in a later stage. It's some kind of timing issues, right? Something like that. Yeah.
Another thing that would be funny was if you didn't write the notification service in JavaScript. Try something else. It isn't much code you need to write in that one. It's very simple. So it would be really funny if you felt confident enough to not write it in JavaScript. Try something else. Yeah.
Yep. And if you still want to use JavaScript, try something else than Express. Maybe you can try another framework or something new, because then you will probably learn something. But it would be nice to see something in Java or C# or Python or Rust.
And since it's a queue, you can't use Express anyways, so it's not a web server.
Yeah, of course. Yeah, that's totally true. Yep. Yep. So with that, do we have anything else to add? It's so quiet.
Yeah.
Look, Niklas, I also have.
Oh, you have like.
Whoa! I should place this one on the top shelf.
Yeah, we should have like. We need to get Mats one also.
Yeah, I should have that. Diego, you need to. Do you have a 3D printer in Växjö? You need to print something.
Yeah, print this yesterday. Like this is like on our printer, which is mind-boggling how it works.
Yeah, it's printed in one piece as well, right?
Yeah.
No assembly required. It just works like that. That's cool. Great. Okay, everybody, good luck with the assignment. And if you have any questions, we are in Slack, as you know. So have a nice one. Bye.